Welcome to another exercise for the workbook Statistics, this time with a unit on the Poisson distribution. Let's have a look at the exercise. Here, first we get the information that snow falls only very rarely on the Egyptian pyramids, and in the last 5 years this only occurred on 7 days. Well, that's interesting to know. What does this tell us? Well, this gives us two information. First off, the snowfall is a very rare occurrence. Whenever we talk about probabilities of rare occurrences, that's where we're going to use the Poisson distribution, because it's also called the distribution of rare events. That's the first information. The second information is 5 years, on average 7 days. So we get an average here based on 5 years. Well, we could also then calculate, based on this information, the average per year. So this information gives us the average. Well, what should we do with this information? First off, calculate the probability that in a year no snow falls at all in Egypt. And second, determine the probability that it snows on more than 2 days. Well, let's start with the first part. As I said before, we're going to use the Poisson distribution here because it's a rare event, and the Poisson distribution is actually the best to use for rare events. We also know from the first task description that we want to calculate the probability that this does not happen, that it does not snow in Egypt, so that we get exactly 0 times this event. So we get P x being equal to 0. We know from the exercise text, as I mentioned, the average. It snows on 7 days over 5 years. So if I divide the 7 by the 5 years, I get 1.4 times of snow per year. So that's the average per year. So I can use this parameter as the average. And well, I know, due to the fact that it's a Poisson distribution, that this factor lambda is equal to my average. So this lambda, which I need in the formula, is actually 1.4 as well. So I have all the information I need. I have the average giving me the parameter lambda. I have the parameter k being the 0 from what I want to calculate here. Meaning I only need the formula for the Poisson distribution, and in the case that I calculate something for one particular case, so here for the case it's equal to 0, that's the formula I'm going to use. E being the Euler number, lambda being this parameter or the average here, k being the 0, so the case I'm considering at this point. Simply plug all of these numbers into the formula, giving me this result. And here I see, well, it's 1.4 to the power of 0. Everything to the power of 0 is always 1. So it's 1 divided by 0 factorial. 0 factorial is also 1. So I have only e to the power of minus 1.4. This gives me 0.2466. Or in other words, 24.66%. So the chance that it will not snow in a year in Egypt is 24.66%. That's already part 1. So let's go directly tackle part B. Again, we know that we're going to use the Poisson distribution. And here, what we actually want to calculate is the probability that it snows more than once. So x being larger than 1. Well, larger than 1, this could be twice, 3 times, 4 times, 5 times, and so forth. It could be an infinite number of times, theoretically. That would be quite a lot of work if we have to calculate all the probabilities by hand. So to make our life a bit easier, we can simply turn this around with the counter probability. So here, instead of going with x being larger than 1, we simply go with 1 minus x being smaller or equal to 1. Why? Well, because this would translate into an easier term, because there's only two numbers which are met by this. This is 0 and 1. And well, the probability of x being equal to 0, we just calculated in part A. So it's actually only one probability we need to calculate in this case. Again, we also know from the exercise text our parameter lambda being 1.4, because it's equal to the average, and the average is 1.4. So we can simply use this rewriting, and as I mentioned, extracting this to 1 minus x being equal to 0 and x being equal to 1, because that's the only two cases which are met by being smaller or equal to 1. And then for this part, we take the result from our exercise part 1 and we just calculate the second part. So that's 1 minus 0.2466, that's from A. And here we're going to use for lambda 1.4, and for k we're going to use 1. Well, 1 factorial is 1, 1.4 to the power of 1 is 1.4, so we multiply this term with the factor 1.4. In total, we therefore get here 1 minus 0.2466 minus 0.3452. And end result, we get 40.82%. So the chance that it snows more than once in Egypt in a year are 40.82%. And that concludes our exercise. So I hope you enjoyed it, and say goodbye. See you next time.